Hey, what's up, you guys? Welcome back to my channel. I have always wanted to say that. For those of you who do not know, I don't think I've told any of you this. I used to make YouTube videos back in middle school. Now, don't try finding them at all. You won't, because I scrubbed them from the internet. But just know that being able to film my own lessons like this, I kind of get to live my YouTuber fantasy right now. So just know I'm having a blast at the moment. Welcome to my office. It's my bedroom. Um, it's going to be a great time. It's going to be super cozy. I filmed my lesson for my senior class already, and I found that I tend to ramble a lot, and it ended up being a little long. So, if you're not quite comfortable, pause this video right now, get yourself a snack, some water, whatever you got to do. Just get cozy, and we're going to talk about some math today. It's going to be great. So, we are just going to move straight into chapter 8. When we were back in school 10,000 years ago, we were on chapter 7, and I'm just going to dump that. We need to move on to the good stuff. So we're going to start chapter 8, which is all about polynomials. It's going to be a great time. And this first section, you guys are going to do amazing at because it's mostly a bunch of stuff that we've already done before in different forms. So we are just going to talk about adding and subtracting polynomials right now. And I know this looks ugly with like this bar across the top. In order to like present this properly, where I can like, use this little pen right here, I have to do it in this weird presenter mode where I have like my search bar on top. It's horrible. But we live and we learn and we adapt and we make it through, which is what I do every day. So it's going to be just fine. So I want to start off with some vocabulary just to get us started. I want to start with term. So a term can be a number, a variable, or a combination of the two. So just some examples. Good old X all by itself. That's a variable. Check. It's a term. You could have something like 7. It's a number. That's a check. That's a term. Or you could get a little crazy this time. You could have 9y. I've got a number. I've got a variable. It's a combo of the two. So that's a term in this case. You could get a little crazier and then maybe have a number, a variable, and then a little exponent on top too. No one said anything about exponents, so you can have those as well. That is also a term. Or you could go extra crazy, go stupid, and have a couple extra. Hold up. There should be a Y right here. You know what? I'm not going to worry about it. Listen, I made this in PowerPoint and then I moved it over to Google so I could, work all this out. So, things happen. That's okay. I'm not going to worry about it. But at the end of the day, a term is just going to be either a number, a variable, or a combination of the two. That's all you need to know. And the second thing I want to talk about is a monomial, which is just going to be one term just sitting all by itself. So pretty much in this case, a term and a monomial are kind of the same thing. It's just whatever a term is, just kind of sitting by itself. So all of these individually, 9y, 7x, 2x to the fifth power, those are all monomials by themselves. So we have been adding and subtracting monomials since like the first day of school. So you are not going to have a problem with it at all. Remember that if I am adding all these weird combos of numbers and variables, it doesn't really matter with what you do with the variables and the exponents because they just need to be the same. So as long as my variables and my exponents on top of them are the same, all I have to do is just add the numbers in front. Remember when I said combining like terms? That's exactly what we're doing right now, only instead of calling them like terms, they're just monomials. So with this first one, they both have x to the 9, x to the 9. One's got a 3 in front of it, the other one has an 8. So I'm just doing 3 plus 8 is 11. Crazy rocket science, I know. With number 2, I've got y to the fifth and y to the fifth on both of them, so they're like terms or monomials. So I just got to do 7 minus 19, which should give you 12, or negative 12, my bad. And then you would include the y to the fifth on the side. We're just going to slap in that variable on there. With number 3, for my people in the audience, whoever's watching, if I just have a variable all by itself, there's no number in front of it, what can we assume that number is? I'm sorry, I can't quite hear you. What? You're going to have to speak up a little bit. Oh, yeah, I got it. Okay, great. It should be 1 right there. So if you don't see a number in front of that variable, it is a 1 in this case. So they both have k to the second power, so I can subtract those numbers in the front. I'm just doing 1 minus 7, which should give you, oh man, let's see if I can work this out. It should be, oh, we're going to figure it out. Negative 6 with that k to the second on top. Just erase this. And then my last one, I promise I will not give you something super crazy like this, where I've got x to the second, y to the sixth, 2 variables mashed together. I just think that can be kind of confusing sometimes, but I just wanted, just a little spice it up, just a little bit. But since they both have an x to the 2 and a y to the 6 on them, I just have to add that 4 and that 3. So it should be 7 with the x2, y to the 6. That's all it's going to be. So we have been doing that since day one. I am not worried about this at all. It's just adding up the like terms. So we're calling them monomials now because why not? So a little bit more vocabulary. We are talking about polynomials in this chapter, which can be one of 2 things. It could be a monomial, which we just talked about, or it could be a bunch of monomials that are either added up or subtracted. So if you've got a polynomial with a bunch of them, they're all going to be separated by an add or subtract sign. And I'll show you what those can look like. Some examples. I could have 2 of them. So I could have 2x to the third plus 9x to the 8th. Notice how, even though they both have the same variable, they've got different exponents. So in this case, you could not do 2 plus 9 in this scenario because one has a 3 exponent, the other one has an 8. So in this case, we're just going to leave it as it is. It's just kind of floating out there in space with 2 terms in it. It would just stay that way. They're separated by a plus sign. That would be a polynomial because we've got more than one. Or you could go extra crazy, go stupid, and have one like this, where one term's got 2 variables, one of them's got 4 and an x, one of them's got 12 and a y, and you could also just have a plain old number without a variable in a polynomial as well. Those are totally legal. But notice how none of these are like terms at all. This one's got x and y, this one's got x, this one's got y, this one's got nothing. So we can't add or subtract any of those. So this whole thing is kind of what you guys would say solved or simplified. It's just floating out there as it is. I'm going to let you know right now, I'm never going to give you one like this. This is absurd. I just wanted to show you what the possibilities were. So just one thing to look out for. I want to know if you guys can tell how many terms are in each polynomial. And it seems a little elementary at this point, but I just want to make sure we're all on the same page. So when I'm asking how many terms, I'm saying how many things are there in the polynomial that are separated by a plus sign or a minus sign. So with number 5, I've got 3x to the second plus 5x to the 7th, or 3x to the second. Wow, second and 7th. They sound exactly the same. English, it's a nightmare language. So in this case, I have 2 terms because I've got the 3x to the second with the plus sign that separates them and then another term. So really all you have to look out for are the plus signs and the minus signs to count all the terms. Number 6 is absolute rocket science. I just have 8x. There's nothing else in it. So in this case, it's just one term. There's no plus or minus sign separating anything else. And don't be fooled by 7. I've got x to the 4th, y to the 3rd. Even though those are 2 different variables, notice how they're slapped up against each other and there's no plus or minus in between them. So that would mean that whole thing is one term all by itself. And then we've got plus 6y and then minus 4. So in this case, I have 1, 2, 3 terms. So you can have terms that have more than one variable in them and they can still be just one thing or one term. So it's just one thing to watch out for. The reason why I bring this up is because the number of terms can determine the type of polynomial. You heard it, that's right. We're going to have a bunch of different types up in here. That's just how it works. So you could have a binomial, which is a polynomial with 2 terms. And when I was thinking of iconic duos, I'm like, God, Phineas and Ferb, obviously, right there. So if you only have two terms in your polynomial, it's considered a binomial. It's nothing special, it's just a label, just a name for it. And if you want to go extra crazy, go stupid, you can have a trinomial, which is a polynomial with three terms. And when I was thinking of iconic trios, I was like, God, the Jonas Brothers, obviously, but not the new Jonas Brothers, where they're all, shaved and like grown up and, married and all that. No, I'm talking about good old preteen emo hair Jonas Brothers, okay? That's the Jonas Brothers that I know, okay? We respect those Jonas Brothers in this house. Let that be known, okay? So, in terms of the ones that we just talked about, those polynomials from before, where I was asking about the number of terms, now we can figure out, okay, what type of polynomial it is. So before with number 5, this had the two terms, that 3x squared plus 5x to the 7th. That's two terms, so we can consider that one to be a binomial. And number 6, that's nothing new because you learned that at the start. I just have 8x, it's one term, so that is a monomial. And this last one with the three separate terms, it's going to be a trinomial. So there's nothing special about those properties at all. It's just saying how many terms they have, and it's a label for it. Just a couple things you need to know. If your polynomial has 4 or 5 terms, they kind of drop off with the special names. They just call it like a 5-term polynomial. So I just care about these first 3. You're not going to have to memorize a whole 1 through 10 numbers worth of those, because that'd be absurd. Last bit of vocabulary. Before I start, I'm just going to get a drink real quick because I can talk a lot. It's good to hydrate, get my voice sounding good. I'm filming this on Monday, April 27th. So this is like your guys' first day of required learning. How's that going? I keep forgetting what subject Monday is for. But whatever that class is, I hope you're doing okay with it. So last bit of vocabulary. First thing we got to figure out is degree of a polynomial. And that's just whatever the biggest exponent in a polynomial is. So if I'm asking you for degree, all you have to do is look at all those exponents in there and tell me which one's the biggest one. And that's the number. That's it. Second thing is the leading coefficient. And that's just the number in front of the variable with the biggest exponent. So it's kind of like two birds, one stone. You're looking for that biggest exponent. Oh, there it is. And then the leading coefficient is just the number that's right in front of it. That's all I'm asking for. So let's fill out this table real quick. Oh, God, I forgot. So I'm a PowerPoint fan. I don't like Google Slides that much, but unfortunately, I had to bring this over into Google Slides, and sometimes the PowerPoint and the Google Slides don't mesh very well. So my table ended up looking ugly as just everything. So I'm going to switch over to PowerPoint real quick because this one looks so much better on PowerPoint. So yeah, we got that. We got that. Ah, look at that. That was my intended thing. Isn't that beautiful? It's so clean cut. Good stuff, my mind. Anyways, so I've got 3 polynomials on the side right here, and I'm asking for a degree, leading coefficient, and number of terms in all of them. And we're just going to fill it out together. So this first polynomial, I got 3x to the third plus 2x to the sixth minus 1. And when I'm asking for a degree, don't forget, I'm looking for the biggest exponent in a polynomial. So we're just going to go right here, scan all these exponents. Oh, boom. There it is. 6. That's the biggest one. And then when I'm asking for leading coefficient, I'm asking for the number in front of the variable with the biggest exponent. So going back to our biggest exponent, cool, it's 6. So, and it's attached to an x. The leading coefficient is going to be the number in front of that x, which we can clearly see is 2 right there. So that's all I'd be looking for in this case. And the number of terms, I'm just counting how many I got. I got 1, 2, 3. So it'd be a trinomial in this case. So try the same with these other ones. This case, I got 4y to the 7th minus y to the 8th. Let's see. My two options for degree are 7 or 8. Which one's the bigger one? Obviously 8. Now for leading coefficient, don't forget what I said. That 8 is attached to the y, but there's no number in front of the y. So what can we assume is in front of that y? I'm sorry, what? You're gonna have to, I'm not getting a whole lot. A little more? Ah, yes, it's a 1. And in this case, there's also a minus in front of there. So in this case, it'd be -1. So watch out for those minuses. Those are killers. And I've got 1, 2 terms, so it's a binomial. Last one, I got -7s to the second power. Well, that one's pretty nice. There's only one term in there, and the only exponent is 2, so my degree is 2, and there's only one leading coefficient. That 2 is attached to an s, which is in front of a -7, so -7 is our leading coefficient. And like I said before, there's only one term, so it's a monomial. So these are the things to look out for. So degree, biggest exponent, leading coefficient, the number that's attached to that exponent. That's all I'm looking for. We good? Cool. So, oh man, where was I? So we're going to go back here. Isn't that awful? I can't believe Google had to do me so dirty like that. Okay. Last thing, and I will leave you alone for the day. So we're going to put it all together and we're going to add or subtract the polynomials. So I put them in parentheses to show you which is one polynomial and which one is the other. So there's no distributing going on at all. There's no multiplication. We're just adding and subtracting. But I'm just showing you, okay, this 8z minus 12, that's one polynomial, and that 6z plus 9, that's another one. So we just got to look out for what are the like terms in this case. So I see 8 and the 6, they both have that z on them, so I have to add them in this case. And this -12 and plus 9, those are both just regular numbers, so I can add those. So I'd want to add those like terms. So you have to do 8z plus 6z, get 14z. And then I've got -12 plus +9. And that's going to give you -3. So in your final answer, you shouldn't have +3. You should have either -3 or plus -3. So it's basically just doing little individual bits of addition and subtraction and then just kind of slapping all those answers together. With number 9, I can clearly see that the 9 has an x3 and the 4 has an x to the 3. So I now want to add those. So 9 plus 4, I'm going to get 12x to the 3. And then I've got regular numbers on the end, plus 3, plus +7. Crazy stuff. I should have +10. So I'd want to have a plus in front of there. And then you might get one like this where I'm going to make you add 3 things individually. So looking at this, I've got x to the 2, x to the 2. So I'd want to add the 6 and the 3. Ooh, I can change my colors. Heck yeah. In the middle, I've got just 2x and minus 5x. So I'd want to add those. And then on the very ends of both of them, I've got regular numbers, +5 and -6. So I'd want to add all of those 3 parts individually and then put all the answers together. So for this one, I'd want to add my 6x to the second, 3x to the 2. So I'm going to have 9x to the 2. And then watch out for these second ones. You want to add 2x plus -5x, which should give you -3. So in your final answer, you should have -3x. Go away. There we go. And then for this final one, we've got 5 plus -6. It's going to give you -1. So in your final answer, it should be -1. I'm just going to put all of those numbers together. So that is what you need to watch out for. 3 more. So, oh no, I forgot that it keeps like all of my penmanship. So I gotta erase it all. Can I make that? Oh, wipe screen clear? Oh, nice. Love computers. Great stuff. So, in these last ones, I've got you subtracting instead, which is a little different. You gotta watch out for that one. In this top one, I've got 7x to the 4th minus 8x to the fourth. So I'd want to subtract those, but don't forget I'm subtracting. And it looks like they're both positive, so we're just going to do 7 minus 8, which should give you -1. And we want to slap that x to the fourth on there. I didn't include the 1, but you can if you want to in your answer, so it should be -1 x to the fourth. And then for my numbers, this is where you really got to watch out for stuff. So I've got a +9 minus -2. So calculators are your best friends. 9 minus -2 is going to give you +11. So you'd want +11 in your answer. So these minus ones are going to be a little tricky. Just make sure to watch out for those. Second one, I got 11n and 5n. I know those are like terms, so I can combine those. So I've got 11n minus 5n. That's kind of nice. They're both positive, so I just got to do 11 minus 5. It should be 6 with the n slapped on top. Last bit, my numbers on the end, my regular numbers, 4 minus 3. Oh, that's nice. They're both positive as well, so it's just a +1, so you'd want to have +1. That's it. That's all you gotta watch out for. And then 13 is a bit of a fun trick that I tried to play on you. So you see I've got 5k to the third plus 3k to the second. Can I add those? Can I do that? I'm being real with all of you. Can I do that? You shouldn't. Because even though they've got the same variables, they have different exponents. So I can't add those. So any stuff that you can't combine, it just gets slapped on there. So part of our answer, we're going to have 5k to the third plus 3k to the second because it's also positive. I can't do anything with those. They just kind of just go in the answer. The only things I can combine are my regular numbers on the end, that +8 plus +7, which is just going to be +15, so you should have +15 on the end. That was a lot of talking. I'm so sorry. For some of you, you probably blasted ahead. For some of you, you might be super confused. So if you have any questions on this, please let me know. I'm going to hopefully set up my office hours, and I'll tell you about those in my email for Tuesday. That's all I wanted to talk about. Thanks for watching my channel. Make sure to hit like and subscribe down below. Hit the bell for those notifications. I forgot to say that part in my topics video for my seniors, so you know I wouldn't forget it for you guys. So that is all I wanted to do for today. I hope you were all surviving okay. I miss all of you desperately. And I just hope you're surviving. Okay, let me know if you got any questions at all. So I can't wait to see you all whenever that is. So have a good day, everyone.